Now that we have the lid pivoting about one edge of the box, how about adding some pivots? Let's add yet another parameter of type boolean, which will be called use pivots. It will be set by default to true, but it will be only used if use lid is also set to true. And of course, we'll change its user interface name. In addition, we'll have two more parameters of float type to define the pivot size and the pivot radius. We'll set the defaults for the size to 10 and for the radius to 1, because we're not going to set them dynamically with the mouse. We need some relatively useful defaults, which should be good enough in this case. Now that we have the parameters, let's also add the corresponding spinners. So we will need the spinner for pivot size. Let's limit this one to the range up to about 100, and the default doesn't really matter because the default is already set in the parameter, but we'll set it to 10 as a reminder. We'll do the same for the radius. The radius will also be limited in a similar range, and we'll change the name too. And we'll need yet another checkbox, and in order to save some space, we're going to place it in the same line as the existing lid checkbox. So we'll add across 2 and add the checkbox for use pivots next to it to the right. Use pivots, pivots. Now we have the controls, but they don't do anything yet. Next thing will be creating the actual pivot geometry and placing it where it belongs. Inside the if use lid do context, that means only in the cases where the lid has been enabled, and after creating the lid itself, we're going to check if the use pivots parameter is also set to true, and if that's the case, we will create yet another geometry instance, but this time not a box. Finally, we'll use something else. This will be a cylinder, which will have the radius equal to the pivot radius, the parameter that we introduced, and we'll use a height equal to the pivot size. We can set the number of sides to 8 in order to avoid using whatever the default for a cylinder is, but we can also implement a spinner if we want to control that parameter. Let's keep it at 8 at this point. We'll need another transformation matrix. Let's call it the pivot TM. Again, identity matrix. This one will require one rotation about the y-axis at 90 degrees, because when we create by default a cylinder, it's pointing up with its local z-axis pointing along the world z-axis, but we want this one to be aligned to the side edge of the box. So we'll first rotate it at 90 degrees, and then we'll set its row 4 parameter to minus width divided by 4 minus the pivot size divided by 2, the length divided by 2, and the height. This is the one position where the pivot will land, and then we will need one mesh. We'll create a local mesh using the typical transform mesh call, but we're not going to immediately assign to the mesh variable. We'll discuss in a second why. In this case, we'll take the, let's call it the pivot cylinder, transform its mesh using the pivot TM, and then we'll repeat about the same. This time we'll start with a fresh identity matrix, rotate again but in the other direction at -90 degrees, use the positive width plus the pivot size divided by 2, same length and height placement, and now we'll add to the mesh variable that contains the whole mesh of our geometry object the result of the addition from the mesh that we created for the one pivot, and we'll add the second pivot to it. We do this because if we would add the first mesh to the existing box, the two would intersect and create long skinny faces along the box due to the Boolean union, and then when the second pivot would come, it would intersect with those new faces, creating possibly even worse faces. If we add the one mesh to the other first and then add the result to the mesh variable, the Boolean union between the box and the two pivots will be created in a single step, and the two pivots will be considered a single mesh, so the final result is a little bit more clean. Finally, because we created a temporal mesh variable containing the tri-mesh of, in this case, the first pivot, we'll delete this mesh so the garbage collection can take care of it. Let's take a look. If we would call evaluate, it looks like we have a bug somewhere. We'll have to take a closer look at what we have found. Here it says that the check use pivots is not found in the user interface, which means that I made an error somewhere. Yeah, I forgot. When I created the use pivots, I didn't put a check in front, so the error message that MaxScript provided me with told me exactly where to look. The parameter block tried to link to a user interface element with the name check chk underscore use pivots, but this checkbox couldn't be found. Let's try again. Evaluate. This time there is no error message. And if we take a look at one of our boxes and check the checkbox on and off in order to refresh the mesh, if we would play the animation now, we see that we have now two cylinders which look like pivots. We can change their size, make them longer and make them thicker if we want. And the other interesting thing is that, as mentioned, they are actually booleaned with the final mesh. We could enable the display of the invisible edges and we'll see how this boolean turned out, but it's not that bad and it's really fast. For every box that we have currently in the scene, we could go and refresh the mesh and we'll get our pivot points. And we can turn them off. If we turn off the lid, even though the pivot points are checked, they are not being drawn because there is no lid and there is no need for pivot points. This is because we put our check for the pivot points within the code inside the test for the lid. So we first test if the lid exists, and then if it does, we also add, in addition to the lid box itself, the two pivots. At this point we could save this version of the script as step 4.